Eric Burgess here. A committee says for a floodlight to properly illuminate an employee exit, it must be mounted as shown, and then you can see my glorious picture here. And it wants us to find the angle of depression. So this thing's supposed to be the light. The angle of depression is referencing how much we have to go down here. So that would be this angle we're interested in. Now we know that this is a right angle, and we want to find this. We know two of the sides, which means that we can find this angle. So this angle, let's give it a name. Let's call it theta. So theta, right, is defined by a thing that is adjacent to it and a thing that is opposite it. And so when you think of that, you should be thinking of tangent. So tangent of theta is equal to opposite 39.82 over adjacent 51.74. Now we can use an inverse function to exchange the places of theta and this ratio. So if we use tangent inverse, we're going to get 39.82 over 51.74 is equal to theta. We're not really switching places. What's happening is we take a tangent inverse on both sides, and the tangents will cancel out on one side and be left on the other. I'm just writing it so that these two things swap. But just to be clear, we're tangent inversing both sides, and the tangents on one side cancel out, leaving us with just theta. So this we can use a calculator for. We have a tangent inverse function right here at the front. Most calculators do. So we're going to take a tangent inverse of this. And I should probably explain why we're focusing on this angle. This angle is of interest to us because there is a geometric theorem that says that if we have two lines in a transversal, and these two lines are parallel, so we have this bottom line, the ground, and we have this top line from the light pole, if you were to imagine a line, this diagonal that crosses them will have the property that the angle formed by right here, this angle theta, will be the same angle that is formed up here. They'll match. So that's why we're interested in this theta. It's the quickest way to get to this angle. So doing this, okay, so we've got our tangent inverse, 39.82. And on the bottom, we've got 51.74. And I didn't write it, but these are technically in feet, which will just tell us the units. We hit enter, and we get 37. I'm going to put a thing here. We're in degrees, by the way. So we have 37.58 degrees. And this is the angle of depression because, as we said earlier, the angle theta here will match this angle. We'll call it phi. We'll say that theta is equal to phi by the transversal rule. I'm not sure what the name of the property is, but that's what we're using here. And so this allows us to tell the angle of depression. Pretty nice. If you have any questions about this, let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.